Welcome! In this series of videos we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the definition and use of string variables. In order to do this, I've set up a small common library to allow us to display information on the screen from a program regardless of whether you're using the Windows or the console compiler. There are three basic functions in this common display library. There's prep output, log, and wait. The prepare output function takes a console name as a parameter, an X and a Y start coordinates, and optional rows and columns. Since this code is designed to work regardless of whether you have the console or the Windows compiler, we're using a conditional if statement, which is handled at compile time, to test if we're actually inside the console compiler or not. So you'll see in here there's an if def pbcc32, which if that's set up we are in the console compiler, and it will prepare the functions accordingly. If we're in the Windows compiler, the same three functions will be prepared, but internally they'll be slightly different. So for the console compiler, we're using a standard console window, and for the Windows compiler, we're using a text window. Today we're going to look at strings within both the Windows and console compilers of PowerBasic. BASIC as a programming language, and PowerBasic in particular, has some very powerful string handling functions, which we're going to look at today. The first type of string we're going to look at is the dynamic variable length string. Declaring these is as simple as putting in the name of the variable and as string to define it as a variable length string. Alternatively, this can also be expressed as follows. Both of these are quite legitimate. So if you come across this in your code to see a $sign at the end of a variable, this is a string variable. You can prefix your variable name with str, or in some cases s, to indicate that it is indeed a string variable. To set the value of your string, it's as simple as putting in the variable name and within double quotes putting in the value. Now, as these are variable length, you do not have to declare the size of the string variable in order to put data into it. You can quite happily add to the string and your string is appended to. This makes it quite easy to add to an existing string. Another type of string you will come across is the Unicode type of string. Now, the Unicode type string does actually involve using more storage for your string, but it will allow you to put accented characters beyond the normal character set. There are a number of different types of character set actually supported, whereas your normal string takes up 1 byte. In Unicode strings, they are set up to handle foreign languages quite happily, but at the cost of actually using 2 bytes rather than 1 byte for each character. However, since modern computers have a great deal of memory, this is not normally a problem. Strings can, of course, be passed to both functions and subroutines, as we're doing up here. If we were to demonstrate that, we would see both strings being passed out to our console window. In this case, it doesn't matter whether the string is actually passed as a variable, in this case, or as an explicit string of characters, as in this case. Effectively, it will be handled exactly the same, without you having to code specially for it. As well as dynamic strings, which are actually set up during the run of the program, you can set up string constants. as so. With a constant string, at compile time, any instance of the constant is replaced by the actual string value. So if we put in here and added in our constant, and we run our program now, the constant details would be passed out just as normal. It's important to note though that constants, obviously being constants, cannot be changed during the run of the program. They are set for the duration of the entire program. But very useful for storing things like file names and things that will not change during the run of the program. Now that handles dynamic strings. Dynamic strings themselves are a very powerful construct. The amount of data you can put into a dynamic string is very, very large, limited only by your available memory. So you can read entire files into a single string, as we do in some of our videos. The other kind of string we're going to look at are the null terminated strings. When you're declaring a null terminated string, you're basically defining the length of the string, in this case as being 10 characters. Anything beyond the 10 characters will not actually go in. The reason this is errored is because we have defined a string of only 10 characters in length, and we're passing this as a parameter to our funlog function. If we have a look in our common display routines, we'll see that funlog is expecting a dynamic string. Now in order to get this to work, what we'll have to do is basically this. We're basically adding nothing, an empty length string onto our string, and it should now work quite happily because PowerBasic will translate all of this into a dynamic string. But you'll see from this when we run it, the string is truncated because it is only 10 characters in length. This can be quite useful if you're dealing with strings of fixed length. For example, reading data in from a file, and you know you always want a 10 character string. This is how you would do it. We can also use properly null terminated strings by creating it using the string z command with a number at the end, and if we run this now, it will print out quite happily. Now one thing to point out about null terminated strings is that null terminated strings are in fact handled slightly differently from dynamic strings. For example, if we're declaring a local null terminated string, they are created so that they use the stack. Now normally it will create by default a stack size of 1 megabyte. So if you're making heavy use of null terminated strings, you may have to use the stack command to increase the size of your available stack space. Now one other string type I'd like to cover is the ASCII Z string computer type. This is something that you will use when you're calling Windows API functions quite often. And to demonstrate this, we're going to create a new function within our application here that's going to pull back the name of the computer that the program is actually running on. And we're going to print this out to our log. In order to do this, we need to use the ASCII Z. Which is a fixed length string, and we're going to be using one of the Windows constants for the max length of the name, and we have two more variables to set up. And the Windows API call we're going to be using is getComputerName, which takes two parameters. The parameter into which we're going to be putting the computer name and the maximum length of that name. And passing back the name to the calling function, or if the call to our API doesn't work, we'll pass back a 0len string. Now we're probably going to have to include the Windows library at the top here. And there we go. There is the name of the computer we're currently running on, which in this case is Octal. So that's a demonstration of how we would use the ASCII format, which is effectively a limited length string, but specifically used to pass information to and from Windows API calls. Now that completes today's video on strings within PowerBasic. Thank you for watching.